going to go ahead and explain to you how you utilize the Jeopardy board to strategize with your team and then run your experiments. But I'm going to focus mainly on the strategizing, and then there will be a subsequent video that will talk about the setting up your stock solution so that you can begin these concentrations and dilutions. Okay, now the first thing I want to name is that the values that I'm using for today. So my category number one is going to be 50 micrograms per milliliter. My category number two value is going to be 10 microliters. My category number three is going to be 0.09 milliliters. I always do that. And then my category number four is going to be 15 micrograms per milliliter. Okay, so to begin, I want to start off by visualizing things. So I'm going to draw my stock solution first. So in my stock solution, I'll just repeat what I have here, 50 micrograms per milliliter. That's what's in my stock solution. And I'll go ahead down here and name this stock solution. All right. And then my category number four is supposed to speak to the desired concentration that I'd like to obtain. So I'm going to make this a little test tube instead of a big stock solution like that. And I'll say that the desired concentration that I want to obtain is 15 micrograms per milliliter. Now, sometimes you'll see concentration in brackets like this. And so I'll go ahead and add that to wherever I have a concentration. 50 and then 15. So sometimes you'll see it like that. Okay. So again, here's my category 1, 2, 3, and 4. And then here is my stock solution. And then here is my desired concentration at the end. Now I'm going to start visualizing my serum dilutions. So the first serum dilution I need to make says that I am going to take 10 microliters of my stock solution and pull it over. But I want you to be aware of something. Do you notice that this is in milliliters? This is also, my desire is also in milliliters, but my stock solution that I'm pulling over that I got from my Jeopardy board is in microliters. So I want to go ahead and change this over because it's confusing to work in different, units and try to convert and everything. You have to convert before you start calculating to make everything so honest. And so here's the formula I want you to keep in mind. I always want you to keep in mind this formula here. 1 milliliter equals 1,000 microliters. Okay, so you keep that in mind and you'll be very well off. So now if I come back here, I'm going to turn this over into milliliters from microliters. And the way that I do that, I like to use my little railroad method. I'll show you what that looks like. Maybe I'll put it down here so it doesn't get out of line with everything. So if I have 10 microliters and I make a little railroad track thing here. No, it sounds funny, but it works. And then I have 1,000 microliters equals 1,000 microliters equals 1 milliliter. Okay. And now what that allows me to do is multiply the top and get 10. Multiply the bottom, it's times 1. So it's 1,000. And then my units that I obtain, I get to cancel off units that are reflective of the top and the bottom that are in a diagonal pattern, just like you see here. So I canceled those and I'm left with milliliters, which is what I wanted. And so if I put this value 10 over 1,000 into my calculator, what I should get is 0.01 milliliters. Okay. So this is the amount I'm going to transfer over instead of that 10 microliters. It's the same thing. It's just in a different unit. So now I can put 0.01 microliters that I'm transferring over. And then what's already in my test tube, what's already in there, should be water, but what amount? That's my category 3. So in my category 3, I selected 0.09 milliliters already. Okay, so there's no reason for me to change or do any other conversions. Let's figure out my dilution factor. My dilution factor equation should be 0.01, which is the amount I'm pulling over from my stock solution, plus nothing, over 0.01 plus what's already in there to get the total amount, 0.09 milliliters. And this is also milliliters. And this should give me, and I'm going to go ahead and use my calculator in front of everybody so you see my values. But okay, so 0.01 plus 0.09 is 0.1, 0.1. And then this top value, which is 0.01. Be very careful of your decimals there. So now I'm going to put that into the calculator to get my dilution factor. So 0.01 divided by 0.1 gives me 0.1. That's my dilution factor. What do I do with that value? Well, I can take my dilution factor now and multiply it times my concentration of my stock solution, and that will tell me what the concentration is in here after I did my first dilution, after I took that first amount out and put it in there. What's my new concentration of this vial? And so I'm going to report that in brackets, and if I do 0.01 times 50, that gives me 5. Okay, so I will report that value right here as 5 micrograms per milliliter. Okay, did I obtain 15? No, I didn't. It's jumped straight from 50 to 5 in just one seer dilution. This is why I am asking everybody to go through their dilutions until they get a whole number with a decimal point and another whole number times 10 to the negative 3 value. This is the concentration, the final concentration that you are going to do until you get there when you're actually in lab. Okay? So I'm going to continue with my dilutions. In order to do my next dilution, I'm just going to keep the same values. I'm doing a serial dilution. So it's still going to be 0.09 milliliters here. And I'm still going to take over 0.01 milliliters from the second vial, well, really is the first vial of my serial dilutions, into the second vial, right? And so in order to get this concentration, really all I need is the previous concentration times the new dilution factor. So we said that my dilution factor was 0.1, right? That was my dilution factor that I took times 50. Well, now I'm going to do that times the 5. And that gives me 0.5. So half micrograms per milliliter. I'm still not at a value, point value times 10 to the negative third. What I am at is I have 0.5, and this also equals, if I take my decimal point over one time, it equals 5.0 times 10 to the negative 1. So I still have a little bit of ways until I get to my negative 3 value. So I have to keep going. So do another dilution of 0.1, 0.09 milliliters, and bring back my calculator again. This time I'm going to take 0.1 times 0.5. So 0.1 is 0.5, and now I'm at this new concentration of 0.05 micrograms per milliliter. Still, I am not at that point number times 10 to the negative third. Why? Because 0.05 is 5.0 times 10 to the, how many times do I need my decimal over? 1, 2. 2. So maybe one more time and I'll be there. Okay? So I'm going to do it again. 0.09 milliliters. And I'm going to move over 0.01 milliliters. Bring back my calculator again. this value here uh, was this concentration in this vial. Okay, so this was this concentration in that vial right there. So I'm going to multiply it times 0.1, and voila, this last vial right here got me to 0.005 micrograms per milliliter. Sorry, that's supposed to be a concentration bracket. Okay, which is 0.005 is equal to 5.0 times 10 to the, let's see how many times, 1, 2, 3. Now we are there. Okay. All right. So I can report how many stereo dilutions did it take to get to that number point. I guess it doesn't have to be a whole number, but it's another value basically times 10 to the -3. And so I will count. That was the first serial dilution, second serial dilution, third, and fourth. It took 4 serial dilutions to get to the number point times 10 to the -3rd value. And that is how you are going to run your dilutions.